Hello, everybody. Welcome to the iHeart Pluto Science Speakers Series with the theme Worlds Revealed. Thank you for joining us as we celebrate the 92nd anniversary of the discovery of Pluto. During this series, we'll have a science speaker every night exploring this theme in different ways. So I invite you to come back and join us each night through February 21st. Tonight's sponsor for the Science Speaker Series is the Runway. My name is Amanda Bosch. I am a planetary scientist at Lowell Observatory and the COO. And I want to introduce Dr. Rudolf Operman. He is a lead systems engineer working at Momentus Incorporated, which is a young in-space transportation company based out of San Jose, California. Prior to joining the Momentus team in May of 2021, Rudy worked at NASA's Jet Propulsion Laboratory as a fault protection engineer on the Mars 2020 Perseverance Rover, Psyche, and the Mars InSight lander missions. Prior to JPL, Rudy worked for Aurora Flight Sciences, a Boeing company, where he designed, built, tested, and supported deployment of several small satellite payloads that are operated in low Earth orbit inside the International Space Station. Rudy's research and career focus spans human spaceflight mitigation, space hardware design, sensor fusion and control, orbital debris mitigation, and space policy, and most recently, robotic space exploration and rendezvous. He has a bachelor's degree in mechanical engineering from the University of Pretoria and advanced degrees in aeronautics, astronautics, as well as technology and policy from MIT, which is where I first met him. So welcome, Rudy, and we're very excited to hear your talk tonight about the moon, Mars, and beyond. So please take it away.
Thank you, Amanda. It's an honor for me to be here. And I will transition by starting my slides screen share here. Please indicate to me if you can see it.
Yes, we can.
Great.
So I'm going to if people have questions as we go, please put them in the chat and we will get them to our speaker.
Thank you very much. As can be seen here from the title, we'll take a look at exploration, specifically focusing on the moon and even more so on Mars, and look at what the next steps are both for NASA and for the space industry as a whole and all the exciting prospects that are lying right ahead. So it's hard to believe that later this year, December of 2022, it'll be 50 years since the last humans set foot on the moon. Here you can see one of the footprints that Buzz Aldrin left when he and Neil Armstrong took that historic first flight back in 1969. Since then, there hasn't been a lot of exploration and no human exploration on the moon. But instead, we have been busy on another planet, our closest neighbor, and the most recent of these endeavors has been the Mars 2020 Perseverance Rover. Here you can see a selfie photo that was taken, from multiple shots taken by the rover on its robotic arm. And to the left, you can see the Ingenuity Helicopter that accompanied it, which was also a historic first to have a vehicle fly with powered flight on another planet. So I'm going to tell you a little bit more about my experience working in this amazing project and how that paves the way for future humans maybe working on Mars one day. This picture, just as a bit of background, shows essentially the family portrait of the rovers that have flown, that NASA has flown on Mars to date. You can see here Sojourner that flew back in the 70s, 1997, and the mission was only for I think about a month, 30 days. And after that, we had the Opportunity and Spirit rovers, the Mars Exploration Rovers twins, that flew at the same time. And you can see progressively as every new mission that NASA sent, the complexity of the rovers grew, the size grew, the scientific instrument complement grew, and most recently, we also flew a helicopter that flew along with the Perseverance rover. So I want to show you a few videos that do a much better job than I would to explain to you some of the intricacies of flying a robotic rover to another planet. And it always gives me chills, and I hope you enjoy these videos as well. And then after that, we can step into some more of the details.
When people look at it, it looks crazy. That's a very natural thing. Sometimes when we look at it, it looks crazy. It is the result of reasoned engineering, thought, but it still looks crazy. To the top of the atmosphere, down to the surface, it takes us 7 minutes. It takes 14 minutes or so for the signal from the spacecraft to make it to Earth. That's how far Mars is away from us. So when we first get word that we've touched the top of the atmosphere, the vehicle has been alive or dead on the surface for at least 7 minutes.
Entry, descent, landing, also known as EDL, is referred to as the 7 minutes of terror, because we've got literally 7 minutes to get from the top of the atmosphere to the surface of Mars, going from 13,000 miles an hour to 0 in perfect sequence, perfect choreography, perfect timing, and the computer has to do it all by itself with no help from the ground. If any one thing doesn't work just right, it's game over.
We slam into the atmosphere and develop so much aerodynamic drag, our heat shield. It heats up and it glows like the surface of the sun. 1,600 degrees.
During entry, the vehicle is not only slowing down violently through the atmosphere, but also we are guiding it like an airplane to be able to land in a very narrow constraint space. This is one of the biggest challenges that we're facing, and one that we have never attempted on Mars.
Mars is actually really hard to slow down because it has just enough atmosphere that you have to deal with it. Otherwise, it will destroy your spacecraft. On the other hand, it doesn't have enough atmosphere to finish the job. We're still going about 1,000 miles an hour. So at that point, we use a parachute.
The parachute is the largest and strongest supersonic parachute that we've ever built to date. It has to be able to withstand 65,000 pounds of force, even though the parachute itself only weighs about 100 pounds.
When it opens up that fast, it's a neck snap.
And other missions that he has worked on. So Hold on one second, please. Am I on? Nobody's on? Hello? Sorry about the technical difficulties, but what we're looking at is hello, are we back on? Looks like we're back. So sorry about the technical difficulties. We're going to try to get Rudolf back on. We have someone heading over there right now to take a look and help him get back online. But we lost the signal in the middle of the 7 moments of terror, which maybe is appropriate because that is, you know, that's one of the things that people worry about when you're trying to land a rover on the surface of Mars, is that maybe you would lose signal and just not even know what's happening. So maybe, so that wasn't intentional, but we added a little bit of a realism there so that everybody could see what would happen if we lost signal. So, we can try to get Dr. Operman back, and we're going to do that. So we're going to just go for a break right here, and then we will be right back as soon as we can get him back online. Okay, thank you. So I'll be right back with Dr. Operman. Wow. So hold on one second. I think that we're just queuing up the slides right now. So let me just wait 1 second here. It looks like we are ready to go. Yes, we are ready to go. So thank you so much, everybody, for bearing with us. It looks like we're going to continue on with this presentation now. So, and thank you, Dr. Operman, for making this happen. So please go ahead and continue.
Absolutely. For those of you who weren't able to see the full video of the Perseverance landing, I would highly recommend if you search it in YouTube, you can see the entire landing sequence. And essentially the video shows everything that we saw in the simulation of the previous video that showed the sequence of events to getting onto Mars during the 7 minutes of terror. We have camera footage showing the heat shield separation, the parachute separation, and finally the sky crane maneuver to land us safely on Mars. So again, I'd highly recommend that you watch that. We're not going to play it here again, just in case it kicks us off again. So I will continue on the different scientific instruments that we flew on this mission. You can see here they listed both the two sets of cameras, the SuperCam and MassCam, that is mounted on this pedestal on top of the rover. These are used to image rock formations far off. We also have the zoomable panoramic cameras. That's also what we use to survey and determine where we want to go next as we explore the surface of Mars. We have a weather station that's mounted on the same boom. So it would measure air pressure, wind. We also have a couple of microphones on the rover that allows us to record sounds on Mars. If you visit the JPL Mars 2020 website, you can hear some of these sounds that's been recorded and learn more about our closest neighbor planet. One that I want to specifically point out to you is the Moxie experiment. This experiment shows at a small scale, it demonstrates how we can extract oxygen out of the carbon dioxide-rich atmosphere of Mars. This has significant implications. If we can scale up this technology, we're able to generate oxygen for future astronauts to breathe on Mars, and also use that oxygen as part of the fueling system to the oxidizer to get back from Mars. So it's pretty critical that we're able to generate oxygen if we want to do human exploration on Mars. And then the other instruments that we have is two different kinds of spectrometers, ultraviolet and X-ray, the Sherlock and Pixel. NASA loves their acronyms, by the way. So each of these stand for something, and I recommend that you look at it. If you're interested, you can find out more. And lastly, a RIMFAX, which is a subsurface radar that's sitting in the back on the belly of the rover. So as we traverse over terrain, we could actually see what it looks like about a meter down underneath the rover. I have another video here, and we'll see.
Oh,
go ahead.
Okay, we have a question for you from Glenn. It says, well, after the presentation, I'll just put this out here, and maybe you can decide when you want to talk about it. But he's interested in hearing about the Lockheed contract to create the rocket that will return Perseverance's core samples, and why was it not done at the same time?
Absolutely. I think let's keep going, and we can circle back to that one at the end. Since it's a little separate, and a few of the slides that we're going to cover touches on the sample return that Glenn mentioned. So I'm going to keep going, but we won't forget about that question. We can circle back to it.
Okay. We also had another question about when you talked about the producing the oxygen from the CO2. Delsamarist wonders where the carbon goes when that happens.
So the system it's fairly intricate, and I'll be honest, I don't know all of the information myself, but it has a filtration system, and the carbon actually gets deposited, and I believe there's a measuring device to see where the carbon would go, and there's a filtration and a cleaning system so that it doesn't clog up the process as the oxygen gets extracted. But that's a good question.
Okay, thank you. That's all the questions we have for now. So continue.
Great. We'll keep going. So here we have a video just showing a very key feature of this rover that wasn't being done before, and that is the sample caching system. So many may be aware that this rover took with it to Mars over 40 sample tubes, and the plan is to fill each of these by drilling into the core samples of interest, different rock formations on Mars surface, and then these would be sealed in these vacuum tubes. They would be sealed up so that no air could get in there, and then deposited in strategic locations on the surface. And as Glenn mentioned, NASA is planning a sample return mission where we would
Okay. Looks like we are going to have to not show videos. I think that's what happened there, is that we lost Rudolf because of a video as well again. So once again, apologies for this, but we are going to get him back online as soon as we can. I'm just sending a note. Okay, so so he was talking about what the rover was doing, which was going around in the near surface in the area where it landed and picking up some samples in these tubes. And so one of the questions that we had from the audience was, what's going to happen to those tubes and how are we going to get them back? So that's something that he's going to have to tell us about. But one of the things that we look at when we go to Mars is not just what the surface composition is and what kinds of rocks we have there on the surface, but looking very specifically at what kinds of trace gases are there, what kinds of things might there be there that would indicate that maybe life has existed in the past. So these are some of the questions that the rover is intending to answer during its mission on the surface. And then when we have to go and get retrieve the sample tubes so that we can actually analyze them and get the answer from that. So once again, I apologize for our technical difficulties, but we are working to get Dr. Operman back online as soon as we can, and we are definitely going to say no more videos for the rest of this one, once we do get him back online. So I appreciate everybody's patience here, and I see Dr. Operman back here. I'm not sure if everybody else does, but so Rudolf, yep, we're back live again, and I've just been telling a little bit of background about what the mission was meant to measure, and I think we're going to have to skip the videos because every time you run a video, we lose you. So, which is very unfortunate. But I'm wondering if, maybe what we can do later is maybe give some links to the audience, and so that people can go and view them on their own when they don't have a Wi-Fi issue. So where we had
Absolutely.
lost you was you were talking about collecting samples at various locations, and that's when we lost you.
Okay, thank you, Amanda. And just to confirm, you can see my screen now?
Yes.
Okay, so I will not play any videos so that we don't go through this again. I will talk to those points. The key thing I wanted to mention with regards to these sample collection tubes, as Glenn mentioned, NASA is in the works of planning a sample return mission that we will collect these tubes and bring them back to Earth. Since here we have more sophisticated science instruments, and the scientists themselves can interact with these samples to look for signs of microbial life. It is very important, however, that all the tubes and all the hardware that we send to Mars is free of any microbial life itself or any pathogens, anything that we might detect later and then claim that we found life on Mars. So we need to be sure that nothing that we take there contaminates the planet. Hence, we call this planetary protection. So all of these sample tubes had to be baked out, make sure they were as clean as can possibly be. And even the rover itself, a lot of precaution is taken to make sure that we don't introduce anything on another planet that wasn't there before. So it's very exciting to see once those sample tubes return and we can investigate further to see what is on Mars. So this next one is a gift. Go ahead.
We have a question from Sophia. She wonders if the rover and helicopter are staying on Mars, and if so, will they continue to transmit information?
Thanks for the question, Sophia. Absolutely. So NASA, typically we plan our missions to Mars to last for a total of 2 years. 2 Earth years is roughly equivalent to 1 Martian year. So if we plan it for 1 Mars year, it would last 2 years here on Earth. So as I mentioned, we're just hitting the 1 year mark for the Perseverance rover. So it's about halfway through its mission. But NASA has been in a very good position that our rovers lasted well beyond their lifespan. You can, as I mentioned, the Curiosity rover that landed back in 2012 is still going strong. It's operating on Mars right now. So it's been alive there for 10 years. And the Spirit and Opportunity rovers before that, one of them lasted 6 years and the other one, I believe, was 14 years. So well beyond what it was designed to do. So we would call it mission success if Perseverance rover lasts through next February. We fully expect that unless something really bad happens, that we can still continue to collect data and do science on Mars for years to come. Here you can see the Ingenuity helicopter that is the first powered flight on a different planet that accompanied the Perseverance rover. And this mission was only supposed to last about a month as a technology demonstration to show that we can actually fly something on a different planet. It has now flown over 18 successful missions, so also well beyond what was considered to be mission success. And it has transitioned into an operational mode. So it is actually flying with the rover far enough away. You can see that top video there. The Ingenuity helicopter, when it took its first flight, this footage was taken with the camera on the mast of the Perseverance rover. So we stood far enough away because if something were to go wrong with the helicopter, the last thing the engineers and scientists at JPL would want is for that to crash into Percy and end both of their missions. But since then, we've grown confident in the abilities of this helicopter. So we've been using it in conjunction to help identify locations for the rover to do some research and collect some samples. You can see in the bottom left there, it's a dual rotor that's counter-rotating design and as light as it can possibly be. Some solar panels on the top to charge it up so it can fly for a few minutes, and then would set back down and charge in the Martian sun. And in the bottom right picture, you can see this is a belly camera inside Ingenuity that takes pictures as it flies. So I want to mention here that to fly on Mars, was there a question?
Oh, no, that's okay. So the camera is the only instrument on the helicopter?
Yes, in fact, it has 2 cameras. Okay. One is looking down, the one you see here, and one is slightly angled, so it's can look in different directions. But because it was a technology demonstration, the plan was that we could fly over a hill or somewhere where it would take the rover much longer to traverse to and identify potential scientific points of interest. So it's not flying any additional sensors, as far as I'm aware, beyond those, but definitely this paves the way for future missions to have systems with more capability, helicopters that can assist in the rover's scientific data collection over there. And I wanted to mention that to be able to fly on Mars is quite interesting because the Martian atmosphere is much less dense than what we have here on Earth. It mainly consists out of carbon dioxide, as was mentioned. And the gravity there is lower than on Earth as well. It's about half, so 3/8 Earth gravity. So if you were on Mars, you could jump higher than you would here. So there's less, the weight is less of a problem to keep a helicopter like this in the air. However, because the air is so thin, it's only about 1% of Earth's atmospheric density. These rotors have to spin much faster to create the same amount of lift to be able to lift even such a small vehicle as this up into the air. So their speed is typically 2,400 revolutions per minute to try and create enough thrust to pull the helicopter into the air. So looking at the preparation, as I mentioned before, we need to take all of these precautions to make sure that we protect the planet that we're visiting. You can see here a part of the team with the rover. This is the flight rover before it launched to Mars, where we're doing some mobility testing. So you can see it's driving around on the 6 wheels.
We haven't changed the, we haven't, oh no. Wow, definitely having some issues tonight. So we have lost Dr. Operman again. Sorry about that. I don't know what's going wrong tonight. We certainly did not have these problems last night. So we will try we'll try to get him back again. Oh, here we are. Okay. So when you switched over to the next slide, we didn't see that, and then we lost you. So maybe if you can start again with that next slide.
Will do. We someone mentioned we're competing with the Super Bowl for bandwidth tonight, and
I think so. Yeah.
I believe so as well. So we'll keep going. If we cut out, I'll just jump right back in, and I apologize that we're running into a few issues here. So this slide, it should be visible on your end now, is the clean room where we assemble our spacecraft prior to sending it off to the launch pad to fly on its Mars mission. You can see here some of the team members in there, what we call the bunny suits. They're wearing these suits, and this is a very special environment where all dust is kept away from the rover using filters and negative pressure, so that we don't, again, put any contaminants, any dust, any human skin cells or hair cells, anything that could potentially end up on Mars and could essentially compromise future scientific findings there. So the hardware is also baked out before it gets assembled. As I mentioned, the sample tubes gets baked in a hot oven as well to make sure that there's nothing that makes its way to Mars that shouldn't be there. Here we're doing a mobility test. You can see the rover is traversing over these blue strips on a terrain to test out all the motors, do testing on the actual flight vehicle before we launch it. Now, one thing to mention here that's also quite unique about a Mars mission is once we've launched, it takes about 6 months, as you saw in the video, for us to get to Mars. There's a launch window that opens every 2 years. That is when the Earth and Mars is relatively close to one another and in the right location so that we can launch and get there with the shortest amount of time and the least amount of fuel. So once that window closes, we have to wait another couple of years before we can send something to Mars again. Now, once we get there, because Mars is further away from the sun than Earth is, a day on Mars is actually a little bit longer than a day on Earth by as much as 40 minutes. So every day, the sun sets 40 minutes later on Mars. So when we first land on Mars, all the engineers that are supporting the mission would go on what we call Mars time. So we essentially adjust our sleep schedules so that we sleep the same time that the rover sleeps when it's dark over there, and then during the daytime when it's transmitting data, or when there are any of our Mars orbiters are passing overhead and it's relaying data from the rover to Earth, we're ready to receive it. So for about 3 months, nominally after we've landed on Mars, we would go on Mars time. So in about two weeks or so, your whole schedule is upside down. You wake up in the middle of the night, you go into work, or during COVID, some of us had to do that remotely. And then another 2 weeks or so, and you're back on a regular schedule. So it's quite interesting if you have a family. But if you have toddlers, maybe your sleep schedule is already a little bit out of whack, so you make do. But definitely a unique experience. And then as soon as we know that all the systems work as expected, we're not seeing anomalies, we're able to switch back to a more regular cadence as we collect data, continue data collection on Mars. I like to call what I had to do on the Perseverance rover I'm trying to break the vehicle, and people's eyes might grow wide at that, but really what that means.
Yep, I was wondering if we were going to lose them again, because I think that we had problems with the slides, and that usually is a hint that we're going to lose his feed. So we are going to, okay, here we go. So I was wondering if we might lose you, because we were still on the bunnies, the clean room slide, and I wasn't sure if that's where we were supposed to be. But you were talking about your role was to try to break things, which is very, yes, my eyes did grow wide when you said that.
And then right after that, we lose the signal. So that might
exactly.
might not be the best time for that.
So I think maybe it's going well.
I will continue on there from that slide on. So I will just reiterate what I mentioned there. So my role as a fault protection engineer on the Perseverance rover was to help our team, the fault protection team, to try and identify ways in that how the system could fail while it's either cruising on its way to Mars or once it's on the surface. So we would do that by doing a lot of simulation testing. Since we have the computer, a flight software that runs the rover, we could inject some faults there, like we could send error messages or something similar. And then we would also do it inside a test bed. Here we would have all of the hardware, what we could typically call a flat sat, or a ground version of all of the smarts that go into a robotic explorer like the Perseverance rover. We would then do different test suites. It could be anything from unplugging a cable to the main computer, or telling it that it is receiving faulty data, to try and see how the automation inside our rover is able to adapt and able to switch maybe to the backup computer or switch out some of the other redundant systems that we have on a rover, because we're not able to see what's going on and intervene from the Earth immediately. As was mentioned in the video, we're, depending on where we are relative to Mars, a one-way light time for a signal to travel from the Earth to Mars could take up to 7 minutes, even more, 10 minutes, so that round-trip light time could be 20 minutes before we send a command and really see what happened with the rover. That is why it's so important for that 7 minutes of terror, the EDL, or entry, descent, and landing operation, to be all autonomous, because we're not able to know what happens before it's too late. So a lot of our work had to do with trying to test out the system, both in the test bed and in simulation. And then finally, some of the select tests. So we would do less tests on the system test venue than we would in simulation. And finally, a few of those tests, the key ones, we would actually perform on the flight vehicle in a very controlled environment to make sure that it would survive some of these faults. And here, wow. I just wanted to share. Go right ahead.
Yep, go ahead, Amanda. No, you keep going. Keep going.
Here is just a photo to show you what it takes to send a rover like this to another planet. An amazing group of people at JPL, engineers and scientists, technicians, all working around the clock to make it happen, and also around the world. A lot of teaming was happening with subcontractors, vendors, research institutes, and academic institutions all around the world to be able to bring a mission like this to the planet of Mars. So speaking about, I just want
to let you know that we're not seeing your slides right now, but I think that's probably a good thing, because that's probably less likely that we would lose you again. But we did see a big group photo flash up before we lost that. So okay. You know, I'm very sorry that we're not getting all of your presentation here, because I know it's has a lot of information there. But yep, there we go. So that's the group photo. And what we might do is, that's a lot of people. You're not kidding. Wow. What we might do
like to
is
point myself out, but it would be hard to do at this distance.
Yeah, I know. What I might suggest here is that maybe let's stop sharing the slides in between, and then you can just maybe pop it up when when you want to show something, because we definitely are having some latency problems tonight. So
okay, I will go ahead and stop sharing then.
Okay, very good. Thank you. We had a question, if I could just jump in right now, about Ingenuity, and if its flight was pre-programmed because of the time delay as well. So I imagine it must be. Is that correct?
Yeah, that is correct. That's a good observation. Because we typically, the way we would do that is we would send commands during whenever we know there's going to be an uplink. So if there is either we have direct line of sight to the rover from Earth, or if we have one of the Mars orbiters flying overhead, it would send information to the rover, and it would send select information over to Ingenuity, telling it that this is the flight profile we would want it to follow. And then it would actually execute that, not in real time for us to see, but then essentially with the next pass, when we get data back, we would evaluate and see how well did it go. We download the pictures, and we can assess if it was successful. And then the helicopter team would then define the next milestones as we go from there. So it's automated, but supervisory control, so that the humans would still be in the loop, and they would say, now is a good time to proceed. And there's some automation built in, like if something goes wrong, that it would try and shut down or land as quick as possible.
Great, thank you.
So we're not going to show any more slides, but I definitely have some more that I would like to, if the audience would entice me to try and imagine these things as I try and describe them to you. And again, I would highly recommend that you can peruse these online, and we'll make some of these links available. You can watch the videos and really get excited about where we are in space exploration, in human space exploration specifically. Because as much as fascinating as it is to be able to collect all of these different kinds of data with a robotic explorer, there's another kind of explorer that can do so much more, and that is a human explorer. If we're able to put humans on a planet, they can make real-time decisions. We don't need that loop back to the ground. If something goes wrong, for instance, our previous Mars explorers, the Mars exploration rovers, Spirit and Opportunity, they would die because of dust being collected on their solar panels. If a human was there, it would very easily use a brush, clean it up, and they can keep going. So as many humans as it took to make a robotic exploration effort like this a success, there's also something to be said. And in my presentation, this would be the enter Mark Watney, the Martian, Matt Damon's character, of what it would be like to be living on another planet. And there are risks and dangers for sure, but the return of gaining that knowledge and exploring and being there is profound. And it's an exciting time for space exploration, because, as I mentioned at the start of the talk, 50 years ago, it was the last time that human boots made footprints on the surface of the moon. And NASA is planning to go back. With the Artemis program, we are actively working on developing the hardware, the rockets, everything that's needed to put humans on the south pole of the moon by as early as 2025. So in only 3 years from now, we will have people on the moon again, ideally for longer durations, and establish a permanent presence there. And one of the main benefits of doing that is to develop these technologies and consider it to be a stepping stone. We can do experiments on the moon. We can develop what we call in situ resource utilization, or ISRU, to extract key things that we need from maybe the water ice that's in the south pole of the moon, or using the regolith to develop build materials and test out things that we would want to be able to do on Mars. But here, the benefit is that we're only about 3 days trip away. So if it's needed, the astronauts can come home. But once you're traveling to Mars, as you saw, the rovers would take maybe 6 to 8 months to get to the Martian surface. And if humans get there, they would be exposed to a lot of adverse effects. Humans' physiology is not well suited for space. When we go into space, there's a lot of different things that happen to us. To name a few is, since on Earth, each one of us are used to having the effect of gravity applied to our body every day. So as we step, we have this loading on our feet, impact loading, so it keeps our muscles and bones strong. But once you're in zero gravity, so imagine you're in your spaceship, you're cruising all the way to Mars, and you are you're in zero gravity, so not subject to the gravity field of Earth. So your muscles and bones begin to atrophy. And that's something that we see on the ISS as well, in the International Space Station. NASA astronauts would have to exercise up to 90 minutes a day for 6 days a week, rigorous exercise to try and maintain their muscle and bone because of these effects. So we have different kinds of exercise equipment on the space station. There's a video for these. I'm not going to play it. But if you Google advanced resistive exercise device on the International Space Station, it's a very cool exercise equipment that was specifically designed for zero gravity. Because if you imagine if you're pumping weights up in space, these weights aren't going to weigh anything. So it's not really going to be that effective. So before this device was developed, both cosmonauts from Russia and astronauts from NASA would use bungee cords to have that resistive element that your muscle has to do work to overcome. But those didn't prove to be very effective. That even though they used them fairly extensively, they still saw muscle atrophy and bone loss. So this system uses 2 vacuum cylinders, and it can generate forces up to 600 pounds. So you can do quite a bit of workout. Again, highly encourage you to look at the videos. So that's one area, that's to do the exercise, which you would have to do throughout your trip to Mars. Because otherwise, if you get there and your bone structure is compromised and you explore on the surface of Mars and you fall, you might break your hip. And the nearest emergency room is 9 months away, maybe even further if you're outside of the launch window. So that's not a good situation to be in. So there are a lot of things that we would have to consider, have all of the resources available on the Martian surface with us if we wanted to establish a colony. But that's very much a goal that many have, including Elon Musk from SpaceX. He is very much adamant to have a self-sustaining Martian colony on Mars, possibly even before NASA sends people to Mars.
Wow. It's really something to think about, just what the possibilities are there. And we have a lot of people on our live stream who are considering that and have come up with a lot of great questions. So one of them, if you don't mind, I'll just go through some of these questions. Absolutely. So John asks if solar radiation would be threatening to life.
Solar radiation is one of the biggest reasons we're not currently on Mars. Radiation, both from solar particle events and galactic cosmic rays, are a very real danger to astronauts, because here on Earth, we're all protected by the Van Allen belts, the magnetosphere that's surrounding the Earth like a cocoon, and it's keeping all of these hazardous radiation away from us. But as soon as you venture out of these belts, either going to the moon or Mars, you get exposed to them. And we don't have sufficient countermeasures to be able to protect against that yet. Quite a few ideas have been proposed, including flying shielding on a spacecraft. Maybe it would be thick, maybe a meter thick pieces of water ice or lead, things that we know would keep radiation out. but that would also mean a lot more mass that we would have to manifest or launch from the Earth. So every gram that you launch costs money. So their solutions have been proposed, but radiation is absolutely an area that we need to do more testing and simulation to try and understand what the effects are, and also potentially through scheduling that we can try and avoid when the sun is most active, that it could potentially affect crew members as they're traveling to both the moon and Mars. Once there, a good solution is to have the habitat submerged. So have maybe a meter or more of lunar regolith or Martian soil covering the habitat. That could also help as a shield to help and try and prevent some of these particles reaching our astronauts.
Wow. Okay. We have another question here from Dulcimerist. Would a crewed mission to Mars be a permanent settlement, or is it possible for a return trip back to Earth?
So NASA is actively working on trying to conduct a mission to Mars. As I mentioned before, the plan is to use the moon as a stepping stone and kind of work out any of the technical difficulties there, given that we're closer and we can intervene if needed. And NASA is definitely planning on having their astronauts return. So, send enough resources and fuel to be able to make that return trip possible. Others, as I mentioned, Elon Musk specifically has grand visions for a settlement on Mars to be self-sufficient, but that takes a lot of effort. I think to receive volunteers who are willing to do a one-way Mars trip would not be hard. In fact, a company out of Europe has tried that before, and many people signed up. I don't know how the loved ones felt about these one-way trips, but from NASA's perspective, we want to be able to return. But for a colony to be there, SpaceX estimates that about 1 million tons of equipment would be needed, so that you can have a sustainable greenhouse to grow the food that you need, to develop the oxygen, to have all the habitats would have to be pressurized. Again, the protection against solar radiation and others. There are a lot of factors to consider, and also when things go wrong, that you have an escape route.
Right. Yeah, there's a lot of planning that needs to go on there. We have another question here, and it's a sort of a thought experiment one. Dagger One asks, what do you think would happen to humans if they were to reside on Mars for many generations? How would the human form change because of
an interesting question.
Gravity on Mars? Yeah.
I think if people stayed on Mars for a long time, it would actually be harder for them to return to Earth, because if you would imagine that you've been on Mars for maybe a generation, all that you know is this Martian gravity that I mentioned before was 3/8 that of Earth. So it's about half of Earth gravity. So if any of them were to return to Earth, they would have a hard time because everything would feel really heavy. They can't jump as high as they used to. It is quite a different setup. I think it would be refreshing in that you can walk outside and take in a deep breath of air, and you don't have to wear a spacesuit or be inside a habitat to do that. And if you think about it, the only environment that you know is the Martian atmosphere or the Martian landscape, it is essentially a red, dead, cold planet, cold desert. So if you were to be able to come to Earth from Mars for the first time, you would just see this beautiful planet for what it really is. All the diversity, the water, the waves. I think it would be fascinating for somebody who hasn't experienced that themselves.
Yeah, it is an interesting thing to think about, because even just living in the desert here in Arizona, when we go to someplace that has more water, just the amount of green that we see is always startling. And so if it's coming from Mars, it would be even more so. We have a question from Sophia asking how the rover gets to Mars. It sounds like it flies there itself, but she's wondering just about, the vehicle that brings it there.
That's a good question, Sophia. Yes, the rover is designed specifically to be just the right, essentially as heavy as it could be to be able to land on Mars using the parachute and the sky crane maneuver that we mentioned. So anything additional weight, in fact, even the cruise stage that accompanies it once we launch it here from Earth, both of them are launched on an Atlas rocket. So a rocket, its only job is to get it up to orbit and essentially point it to Mars, fire its second stage to get it to speed so that it can make it out there. And then that rocket falls away. Both the first and second stage would no longer be attached, so that, again, we want the minimum amount of additional hardware that we don't need to go with us. We have a cruise stage that have a set of solar panels. Recall in the video, the very first image that we saw was this little, it looked like a donut almost on the back of the enshrined rover with the heat shield in the front and the backplate behind it. So this cruise stage would have some additional solar panels to generate power and also have what we call an ACS, so attitude control system. So it has some fuel and thrusters on there. And we use that to do course corrections throughout the 6 to 8 months that we fly to Mars. So the orbital mechanics to get a rover to Mars is quite fascinating, that even if we don't launch, depending on conditions here on Earth, say if we missed the launch by a few days because of bad weather at Cape Canaveral, by doing these course corrections along the way, we're still able to land on the same day over at Mars. So as we get closer and closer, we would slightly correct to make sure that we hit our target on the right time once we get there 6 months later.
Okay, cool. We have another question from Mr. Angel asking about static dust and whether or not it's a large problem for future Marsonauts, astronauts on Mars.
Yes, I like that. I like the Marsonauts. Dust is absolutely an issue. Both, you can see some of the footage of the pictures that all of our rovers on Mars have taken to date. Everything is dusty, this red rust-like dust that covers everything, including our optics. So a lot of our cameras we have to protect. They have dust covers on them while we land, especially with all the dust that's been kicked off, as you saw when we did the sky crane maneuver. And then this dust does settle over time, but it is absolutely an issue. So systems need to be designed to handle that dust. And then for humans as well, a big thing that came out of the Apollo missions back in the 60s is that the lunar regolith, or the dust that we find on the moon, is very abrasive. It actually, if you look at it under a microscope, it's very jagged little pieces, and it would actually damage the suits, damage the bearings within the different parts of the suits where they move, maybe on the wrists or around the elbows or the shoulders specifically. And even for the astronauts, they obviously didn't breathe in when they were outside, but they had to sleep inside the lunar module. So whenever they came in, they would take their suits off. So the suits would be in the same pressurized environment as them. And they actually would develop respiratory issues because these fine particles of dust that's so abrasive would get into their lungs. And there was coughing, and it was not a pleasant experience for them. And again, this dust gets in everywhere. So a lot of the engineering challenges with developing lunar rovers, Martian rovers, is to think about the dust problem and to design around it. I think a big part of sending humans to live both on the moon and Mars more long term would be to have effective cleaning systems inside of the airlocks whenever somebody comes in or out of the habitat, so they don't track all of that dust into the rest of the living space.
Absolutely, that's right. Dust is enough of a problem here. I just wanted to let people know that we're going to go a few minutes past our nominal end time, just because we lost some time with our network issues, which does seem to be due to the Super Bowl. So we're just going to continue on with a couple other questions here, if you're okay with that. One of them is asking about whether or not we can send programmable rovers that can do excavation and construction before the first crewed mission arrives.
Absolutely, and I think that's a great way to do it. A lot of the work if we could send essentially supplies, and as I mentioned before, the Moxie experiment that's currently generating oxygen on board the Perseverance rover on Mars. I think to date, the last number that I saw is we've generated 50 grams of oxygen, which is not a lot. But again, the idea is that we've demonstrated this technology works, and the next step would be to scale it up so that we can generate sufficient amounts. So you would sense a system like this well in advance. It would go to the Martian surface and start generating oxygen and storing it. So by the time humans arrive, that there's a good supply of oxygen for them. And then from that, we can also get the liquid oxygen that would be used in the propulsion to get back to Earth. So something like that would go early on. I think we've seen on Earth, the robotics have really taken off, that we can have rovers that could start building a habitat like the one that we discussed. They could maybe build it, maybe using additive manufacturing techniques that we see here on the ground, essentially building the habitat, and then ultimately maybe plowing some of the soil over it to get that protection from the radiation, as we talked about. And I think we'll actually see that on the moon as well. A lot of
That's a good
robotic
point.
assistants, little rovers, all kinds of different robots that can help make the job easier for astronauts, both on the moon and Mars.
Well, Cody has an interesting question. She wonders if you would live on Mars if you had the chance.
That's a good question. Depends who you ask. If you ask my wife, then the answer is going to be no. I would caveat it with, I would not want to be the first person to go. While there's definitely the sense of exploration and adventure, there's a lot of risk involved, but there are absolutely people who want to do it. I know, again, Elon Musk, who is the billionaire who is very successful with his space company, SpaceX. He was asked the same question, and he said he didn't want to be the first one on Mars, but he would like to be buried on Mars. So at one point he would go there, and that would essentially be his Florida retirement home on the deserts of Mars. So I would love to go to space. I think I'd love to go to the moon. Again, I would have to get some buy-in from some family members. Mars, I think, is the way it is right now. There's definitely the aspect of it's new and exciting. But I think, again, if you're there over an extended period of time, if there's not enough to keep you engaged and maybe ways to remind you of Earth, and especially if you're going to have to be there for at least 2 years at a time, it might be tough. But I absolutely think that there are ways to create a thriving society there, like I said, with greenhouses, with plants and features that I think it could be exciting for sure.
Absolutely, that would be. All right, so we're going to. We could continue talking to you just for hours about space and all the various the missions that you have worked on. So I will let people know that we will be having a podcast with Dr. Operman coming up, and so you can look for that later. It's the Lowell Observatory Star Stuff podcast, which you can find where you can, at wherever you get your podcasts. And so we'll continue this conversation, maybe talk about some of the other things that you've done during that podcast. So we're looking forward to that. So I just definitely wanted to thank you so much, Dr. Operman, for coming here and just sharing with us your experiences on the Mars 2020 mission and talking about the what the possibilities are. And thank you again for your perseverance on working through all of these internet issues that we had. And thank you to our guests as well. So I want to once again thank our sponsor for tonight, which is the Runway. And I'm going to just end it here and just remind everybody that we have the science series. We have talks coming every night except for Friday the 18th. So we look forward to seeing you again on another one of these science series talks. And thank you, Dr. Operman, very much.
Thank you very much.